Hi, my name is Stephen, and today we're going to be discussing how the brain breaks down words in Tagalog. But first, a little game. So, in Tagalog, many verbs are formed by using the prefix mang plus the root word. So, for example, mang plus hila would be manghila, meaning to pull. Now, I want you to guess what the following would make: mang plus bulag and mang plus tulak. Now, pause the video and come back. Let me know. So if you guessed Mangbulag, I am so sorry, that is incorrect. If you also guessed Mangtulak, I am so sorry, that is also incorrect.
Huh?
So what exactly happened here? The words are actually Mambulag and Manulak. So you might ask yourself, what happened to the NG? Well, here, phonological processes change the sound of the prefix, which obscures the boundary between the prefix and the stem or the root word. When we read words, the brain often breaks them into morphemes. Think of it like Lego, being dismantled into a few pieces. And these morphemes are the smallest units of meaning. For example, teacher would be teach plus ER. This is morphological decomposition. Many models of visual word recognition propose that readers automatically break words into morphemes during early stages of processing. However, most studies have only focused on language like English, where morpheme boundaries are very clear and visible. Languages like Tagalog, however, which I speak, have boundaries that can be obscured by phonological changes, just like you've seen. Now, this brings us to research by Cayado et al., a paper fittingly published by a Filipino. So the key question of their study is, does morphological decomposition still occur when phonological processes obscure the boundary between morphemes? In simpler terms, can readers still recognize the stem of a word even when parts of it are hidden or changed? They hypothesized that they could. The researchers tested this using two experiments, where 80 native Tagalog speakers were recruited. First, a behavioral mask priming experiment. Participants formed a mask priming lexical decision task, where a word appears briefly as a prime, then is followed by a target word. They compared related and unrelated pairs. So, for example, mambulag followed by bulag would be a related pair of prime target word. This experiment wanted to see if the brain decomposes the word into morphemes. Participants should recognize the stem faster. And the second experiment that they used, magnoencephalography or MEG study, to measure brain activity during word recognition. The researchers examined activity in the left fusiform gyrus, part of the visual word form area, focusing on M170 response, which reflects early visual word processing. So in the behavioral results, you can see that the related pairs and unrelated pairs showed a significant difference. In fact, the related pairs showed a lower reaction time than the unrelated pairs. Importantly, this effect occurred when the boundary between the prefix and the stem was obscured by phonological changes, so it was unclear. This study suggests that the readers still automatically activate the stem representation during word recognition. So here, morphological decomposition still occurs. Now, in the MEG experiment, they showed that the left fusiform gyrus, the brain region that was analyzed in the study, actually showed activity. And panel B here on the top right plots the brain activity in this region against stem whole word transition probability, which reflects how strongly a word can be decomposed into a prefix and a stem. The consistent trend across the three conditions indicates that brain activity tracks morphological structure, even when phonological changes obscure the boundary. This suggests that the brain detects morphological structure very early during word recognition. So, overall, Cayado et al. Showed that morphological decomposition occurs even when morpheme boundaries are obscured or changed or whatever. Both both behavioral priming and MEG evidence suggest that the brain detects morphological structure very early during visual word recognition. And these findings in Tagalog support existing models of visual word recognition. It also shows that these obscurities of morphemes are evidences that Tagalog is shaped by statistical properties of the writing system. One limitation of this study is that it only focuses on Tagalog, so results may not generalize to other similar languages. In addition, the study also focused on early visual processing and did not seek later stages of processing to be assessed. And a future direction is hopefully that they could redo or replicate the study with cross-linguistic comparisons and see if similar processing occurs in other languages. And this is my AI use statement. I searched this paper in APA Info using these terms. I used ChatGPT for clarifying terminology and outlining my presentation. Slides are by me, and this is my only reference. Thank you for listening.